Hi, welcome back. We are talking about Faraday's and Lenz's laws. So I've got an example here. Find the voltage that is induced in side 2, the right side of the magnetic circuit, if a time-varying voltage V1 is connected to side 1, right, which is the left side. Suppose the sides have turns N1 and N2 respectively. All right, this is actually a very useful example, and I'll say a little bit more about that at the end of the example. But now, so side 1 has this current that's going through each coil, right, I1, and that current produces a magnetic flux through each coil psi. And so if there are N1 turns, then the total flux on side 1 is N1 times psi. And then according to Faraday's law, V1, that voltage, then is negative N1 d psi dt, like that. Now, all of that flux then goes, and we talked about magnetic circuits before, all of that flux goes through side 2. So that must mean then that the voltage V2 is negative N2 d psi dt. So notice the psi doesn't get a subscript because it's the same psi in either case. So if we equate those two things, we see that V1, we see that N1, what is it that I want to say here? Yeah, so if I solve for d psi dt in the first equation, call this equation 1, and I put it into equation 2, what we get is V2 of t equals negative N2 times V1 of t over negative N1, like that. Okay, actually. Right, so again, that was just solving equation 1 for d psi dt by dividing by negative N1, and then putting that into d psi dt in equation 2. And so this is what we get here. And so the negatives cancel, right? And what we see is that the voltage on the other side, the right side, is N2 over N1 times the voltage on the left side. So this is pretty neat then. This is a way to step up or step down the voltage. So if I have a little bit of voltage on the left and I want a lot, then I need to adjust this ratio, which is called the turn ratio. So if I make N2 larger than N1, then this fraction is greater than 1, and the voltage on the right is going to be more than the voltage on the left. And if I need to step down the voltage, then I'll make the turns N2 less than the turns on the left N1, so this fraction is less than 1, and so then when I multiply that by the voltage on the left, I get a smaller number than the voltage on the left. This is called a transformer. That's exactly how a transformer works. It works to transform the amplitude of V2 or I guess it transforms the amplitude of V1 based on the turns ratio N2 over N1. So let me just be concrete here. Let's suppose V1 was some sinusoid, like 120 volts cosine of some frequency, okay, like that. And let's say that the number of turns N1, let's say N1 was twice the turns N2. So then this fraction, or this fraction here, is 1/2, and then what you get at the output, or on the right, is 60. So you actually step down your voltage by 1/2, so you get 60 volts.